So we're checking our homework, number 5, 6, and 7. On number 5, the component form is 10, 6. Our magnitude is 2 square root of 34. Do you agree with that? You got to break down square root of 136. Number 6, the component is 6, negative 3. Magnitude is 3 square root of 5. Now, I did this late last night, so if I made a mistake, tell me I don't agree with that. Let me recheck it. Number 7, the component forms negative 6, negative 14. The magnitude is 2 square root of 58. You have to break 232 down. Are there any questions on 5 through 7? Number 27, 28, I got to write the vector in the form AI plus BJ. What is that form called? Linear what? Combination. Very good. So I got A equals 6 times cosine of 30. B equals 6 times sine of 30. And you arrive at these answers. A is 3 square root of 3. B is 3. So I have 3 square root of 3i plus 3j. 28, I have it set up as A equals 8 cosine 45. B is 8 times sine of 45. And I arrive at 4 square root of 2 for both of them. So I have 4 square root of 2i plus 4 square root of 2j. Square root of 2j. And then 29, A equals 12 cosine of 225. B equals 12 sine of 225. And you arrive at negative 6 square root of 2 for both of them. So the final answer is negative 6 square root of 2i minus 6 square root of 2j. We good on those? You good?
I figured out what I was getting the wrong answer.
What page are we on? Please, let me see. Well, I'm proud of you that you figured that out. But I got a question. Will Mr. Henry give you something we hadn't looked at? Okay.
I don't know what else there.
That's all right.
I said it was late last night.
All right, turn back to page 2. Back to page 2. We started with operations with vectors algebraically. Yesterday, and we found that those are pretty easy. Would y'all agree? We got one more. On number 12, what does that mean to do on number 12? Very good, Ivy. So we need to find the magnitude of each of them and then add them together. Order of operation. Do what's inside your grouping symbols. Okay, so let's find the magnitude of V. So this will be 3 squared plus negative 5 squared. 9 plus 25, that's square root of 34. Break 34 down to 2 times 17, so I really can't break that down. Now I'm going to find the magnitude of W. That's negative 2 squared plus 3 squared, which is 4 plus 9, which is 13. So now I'm going to say square root of 34 plus square root of 13. Can I add those two? Can I combine those? So that's your answer. Yes. All right. Are there any questions on that? So yesterday I told you we're going to perform operations algebraically and geometrically. So yesterday we performed operations with vectors algebraically. Today we're going to do it geometrically. And how do I tell you? How do you do it geometrically? You're drawing them. Okay, you're drawing them. So that's what we're about to do here. It says find the following. It's easy to do it on graph paper, and that's why you see you got some graph paper here. On 15, it says A plus B. Well, first of all, let's look at A, B, and C. You need to do this before you even start. Look at vector A. You got to find its components. So let's do this. I went 1, 2, 3, down 3, didn't I? Down 3. and 1, 2, 3, right 3. So if you want to do down 3 arrow, right 3, whatever helps you know that you're going to use that to help draw these vectors. So from my initial to my terminal, I went down 3, right 3. So whatever symbols you want to use there, okay? Okay, I don't like B, so we're going to draw another B. So this is how I want to draw B. Down 1, left 3. Down 1, left 3. So just draw you a new B over here. Down 1, left 3. What would be vector C? Up how many? Up 4. And then over how many? Right 6. Okay? So if you want to do that first, so go on show which way you're connecting, go for it. Because you got to be able to draw it. Can everybody see that? Are we good with that before we start? Okay. Okay, so 15 is A plus B. So you start off by drawing A again. Okay, so I'm going to draw A right here. So this is number 15, A plus B. So I'm going to pick this right here. I'm going to have me a starting point, my initial point. I'm going to copy A. What I do is go up or down 3. 1, 2, 3, over how many?
3.
Okay. Now this is where you need to pay attention. Where do you start for the next vector drawing? You start at the head of the first one. Okay? So I want B. B is what? Down 1 and over how many? 1, 2, 3. So you start at the head and then draw the second vector. A plus B is represented by the line that connects these two vectors. Okay, that represents the sum of the two vectors. Now it's very important that you know how to draw that last one. It's called the resultant. It's the result of the sum of these two, okay? Resultant. Alright, so you draw that final vector from the tail of the first one to the head of the second one. So tail of the first one to the head of the second one. And that is A plus B. That represents A plus B. So I'm going to label each side. I'm going to label this as vector A, vector B, and then that right there is the sum of vector A plus B. And that's all you do on that. You won't get a number, you get a drawing.
Why would it not just be like one line over A plus B?
That connects the two, so that shows that it's the sum of the distance. Alright, let's look at number 16. A minus B. A minus B. Start off, we're drawing A. Down 3, 1, 2, 3. Over 1, 2, 3. What do you think we would do with minus B? Go in opposite direction of both parts of B, okay? So if B is go down 1, we're going to go what? If we were going left 3, we're going what? That's how you draw that, okay? So instead of going down 1, I'm going to go right up 1 and then to the right 3 instead of left. 1, 2, 3. So I would label this as vector A with that symbol. I'm going to make sure I put negative B to let them know that that was a negative B. And then I'm going to draw my resultant. It's from the tail of the first one to the head of the second one. And then put that's A minus B. It's not too bad, is it? about 2b? What would you do on just 2b? Scalar multiplication. Multiply both components by what? 2. Yep. So on B, instead of going down 1, you're going down how much? 2. Instead of going left 3, you're going how much? 6. Left 6. So I'm going to start here, and I'm going to go down 2, and over 1, 2, 3, 4, 5, 6. And that is vector 2b. Alright, negative c. Instead of going up 4, I'm going to go what? Down 4. Start with the initial point. 1, 2, 3, 4. And then right or left 6? Left, because the original was right. 1, 2, 3, 4, 5, 6. And that is my negative c vector. Now, when I was in high school, my teacher didn't let me use graph paper. We had to get an inch ruler out and measure the vector and make sure we constructed it just. But with graph paper, you can easily draw it.
Did they not have graph paper back then?
I'm not that old. Yes, they had graph paper. It was a lot more. Physics was a lot more about vectors back then. Now y'all do a lot more experiments in physics. Let's just change 19 to A plus 2C. A plus 2C. Alright, so A plus 2C. I'm going to start off with A. Go down 3, 1, 2, 3. Over 1, 2, 3. And then 2 times C. Instead of going up 4, I'm going to go up how much? 1, 2, 3, 4, 5, 6, 7, 8. And instead of going over 6, I'm going to go over what? I'm going to run out of room, guys. Okay, I ran out of room, but do you get the concept? Let me see if I can come down here and do it. It looks something like that down here in the corner. Very important. Key things I want you to do. You got to label it right. A with the little vector notation above it. 2 with the C with the little vector. Make sure you label it, okay? Is everybody good with that? Okay. Alright. Let's talk about this for a minute before I try to explain the next thing to you on the bottom. Let's say we had this vector right here. Alright. So let's look at this picture here. Vector A plus vector B equals vector C. I know that because it starts at the initial and ends at the terminal of the second one. Do y'all see that? The way it's correctly drawn. You might see this, and I usually don't show this before I teach the next thing, but this is confusing, so I was going to try something different this year. Vector A plus vector B, what's different about the C over here? It's going the opposite direction. Instead of starting at the initial of the first, it's starting initial of the second. Well, you can write this statement if you include that negative sign right there. What does negative mean in math? Opposite. So if you saw this, this is a true statement, okay? So I just wanted you to be aware of that. You don't see that a lot, but you can see that, okay? So let's look at the next part here. Well, the only time I've ever seen it was in diagrams like this, so I just wanted you to see that before we start analyzing this picture right here, okay? It says, use the figure to the right, determine whether the given statement is true or false. If it's false, change one side of the equation to make it true. Now, we're going to go in different order because I'm starting with some easier ones before we get to harder ones, okay? So just follow along with me. Let's start with number 20. And let's see if it's written the way if the picture matches up with the equation, okay? It says vector A plus vector B equals vector F. You said, why doesn't it have the notation like the little vector? Because they can bold print stuff. We can't, so that's why we have to use the little notation this above it. Does everybody see that? The vector notation? Okay. So let's look at our picture. A plus B. Okay, they've drawn it correctly so far. Initial to head. Initial to head. Do you see that? So here's your first vector. They started the second vector at the head of the first one. You see that? Now let's see how the resultant is drawn. Are they drawing the initial at the initial of the first one? And the head is up here? So is that correct? That is a true statement. Because this arrow belongs to this to G down there. That arrow is G. Alright, let's look at 23. We didn't talk about this. It says A plus B plus K plus G equals 0. If you start at one spot and keep adding vectors around it till you get back to your original start, that equals 0. That's just a rule in vectors, okay? So, let's look here. Let's see if it's drawn correctly. A plus B plus K plus G. Did I end back up? Did I draw it correctly? That's a true statement. A plus B plus C plus H plus G. Did I end back up at the same spot? That's true. Alright, now let's go 21. Let's pay very close attention to this, okay? D minus E. Okay, so let's talk about that. It says D minus E. Well, normally D plus E, the head, the initial would start here and go that way, the arrow wouldn't. But here you see the arrow is backed up to the arrow. So is that opposite direction? So we're good so far, okay? Does that make sense why? D minus E, okay, F, the initial starts here. Is that drawn correctly? Yes. Now let's look at C. C has the arrow down here, doesn't it? If that was drawn correctly, wouldn't it be initial here and head at the final spot? Do you see that? So that is false, but how could I make that true? By changing C to what? Negative C. Changing C to negative C, because if it's drawn correctly, it would be initial at the initial, head at the end.
I still don't get how that works.
Okay, let's just keep practicing. Just remember that negative means it's drawn opposite. Usually, if you have this, if this is your first vector, and you're drawing the next one, the initial will be here, and then the arrow will be down here. But since we saw a while ago, we drew the first one, and then the arrow is right here, it was in opposite direction of what it should have been. So that's why you had a minus a vector. Alright, let's look at 24. K plus G, that's drawn correctly, isn't it? Equals F. Is F drawn correctly? So would that be true or false? False, and how would I change that? To negative F, wouldn't I? You can't change a picture, but you can change the equation. Number 22. E plus D. E plus D. Well, the first one's E. That D should have started the initial point there, shouldn't it? So how could I change that? E what? Minus D. E minus D. In the big scheme of things, this is not the most important thing, but you do have 2 or 3 questions like this on test, so I go over this.
Basically, the start point has to hit both of them.
What do you mean start point?
You're starting with
E, if this was drawn correctly, E would be first, and then the initial point of D would be right here. But since it's not, we have to put that minus in there because it's drawn opposite of what it should have been. Let's look at 27, then we're going to go on to something else.
I have a question.
Yes.
So if you, like, we had to change D, so do you just, like, forget the second half of that?
Yes. Yeah, you're good. I'm not going to give you one like that on the test. 27, K plus H. K, is H drawn correctly? So I would put false and put what? K minus H. Okay, we're going to review diagrams like this every day, so it's going to start making sense on that, okay? All right, let's review something before we go on to something else. We're not going to do 25 right now. Looking at this, back to the drawings. You start with your first vector, initial, tail to head. When do you start the next vector? At its what? Head, and then go on. And then connect from the tail of the first one to the head of the what? Are we good on that? Okay, let's turn to the next page. What's your next page? This is real easy. Page 3, okay? I wasn't going to do this because we're going to be out tomorrow. Let's go on and do it. Okay, so far we've done addition, subtraction, multiplication for vectors. Okay, vectors does not have the operation division. Division is not defined for vectors. So I would never give you a division problem for vectors. But they do have a fourth operation that is exclusive to the vectors. It's called the dot product. Okay, so they have addition, subtraction, multiplication, and the dot product. Okay? And it's very easy, and you're going to be bored to death. Here we go. Page 3. We want to find the dot product for number 1. Are you ready for this? Ready? Watch because it goes quick. You multiply the first ones, negative 3 times 3. Put a plus, and then 4 times 6. And your answer is 15. That's all you do for the dot product. You multiply the corresponding parts. Negative 3 times 3. Were you joking?
Yeah, I was
Oh, I thought you were serious. I said, oh God, Nick didn't get it. Alright. Number 2. What am I multiply 2 by? What am I going to multiply 7 by? 4. 2 times negative 14 is? Plus 28 is? 0. Very good. 2 more examples. We're done. We're halfway through this unit. Is this easy to y'all? What you think, Sydney? Okay, 2 vectors with a dot product of 0 are said to be, you're about to learn a vocabulary word, orthogonal. Say orthogonal. Orthogonal just means they're perpendicular. That means the 2 vectors intersect at a what angle? 90 degrees. So if you get a dot product of 0, that means that these 2 vectors are orthogonal. That means that they intersect at a 90 degree angle. Okay, so let's look at now 3. It wants to know if it's orthogonal or not. Well, you got to do the dot product. So number 3, 3 times negative 5 plus negative 2 times 1. Negative 15 plus negative 2 gives you negative 17. Is that orthogonal? No. Number 4, negative 2 times 9 plus negative 3 times negative 6. That gives me negative 18 plus 18, which is what? 0. Are they orthogonal? Yes. Huh? Oh, yes, I'm sorry.
So would the 0 on the top one be orthogonal too?
Yes. Orthogonal means they intersect at a right angle. Yes. Oh, that's wrong up there. Okay, yes. Yes. Oh, very good. Thank you, Holly. All right. That's what I'm telling you. On page 11 at the top, 1 and number 2, it's fine. It's got like 3a plus b, and you got to do the drawing. Use the vectors that were in our notes, okay? Like the a and the b. Use those and do it on graph paper, okay? Thank you, Holly. In your homework, you got to draw some vectors. Use this a, b, and c that you had in your notes, okay? Yes, you might.